ठीक है ना, ये रखना और ये वॉल्यूम अभी जो बोल रहे वही आ रहा है, ठीक है ना। उसमें ये बंद मत करो। मिलते हैं, बाय।
इसको मैं लेके जाता हूँ।
हाँ
सुनो, कल मैं घर पे जा रहा हूँ, कल दूसरे भाई को कॉन्टेक्ट करके ये ले लेना।
तो किधर होके जा रहे हो? अहमदाबाद होगा, गाड़ी लेके जा रहे हो?
बस में जा रहा हूँ। आपको रात कितने बजे आपको निकलोगे वहाँ से?
मैं तो 7-7:30 फ्री हो जाऊँगा।
हाँ तो लेके ही जाना ना आप।
कहाँ से?
घर पर से यहाँ
मैं जा रहा हूँ सजा सुनना है, क्या बोलते हैं, साणंद।
बाइक पर
इधर से डायरेक्ट साणंद जाऊँगा, साणंद से प्रोग्राम खत्म कर घर जाऊँगा। आपका खत्म कितने बजे होता है? फ़ोन कर देना मुझे, खत्म होने से 5 मिनट पहले मैं बंद कर दूँगा।
हाँ कोई बात नहीं।
लेकिन दूसरा ये चलने देना कुछ नहीं, बैटरी देखते रहना, बैटरी चार्जर लगा
तो लाओ, लगा देता हूँ थोड़ा, लाओ चार्जर लगा देता हूँ।
अटेंडेंस शीट क्या છે? હા બરાબર રોટેટ અહીંયા કરીને આ સાઈડ આપજો. હા બરાબર
खत्म होने में कॉल करता हूँ।
બધું જઈ
You may have a seat, please. So, good afternoon, good evening, whatever it is. Sorry for the delay. I should introduce now our today's speaker, Professor Bhaskar Kamble. Yeah. Thanks a lot, sir, for coming here. We all heartily welcomes you, Indian Institute of Teacher Education and GUJCOST, on behalf of both of the things we are inviting. I welcome sir, his father, madam, I don't know the names, even that tiny ma'am. We heartily welcome you. I request Professor Kamble to just brief us about what he is going to talk on and how his lecture will be, and then after we'll proceed with the formal inaugural part and all sort of things. I should introduce him first, just a brief introduction. He is right now working as a data scientist in Germany. He has done the PhD from IIT Kanpur, and he is basically physicist, so physics and maths people can have a lot of interest in his talk, I think. So, sir, please introduce, give some brief idea about your talk and what you are going to brief us. Thank you, sir.
Yeah, thanks a lot for this kind introduction. Which language do you prefer? Should I speak in English or should I speak in Hindi? It's okay, right? I think I'll just keep shifting as and when the need arises. Yeah. So, so I'll kind of talk about a subject which is very close to my heart. That is the history of mathematics in the Indian subcontinent, which is called as Hindu mathematics, which I've called as Hindu mathematics. Some people call it also Indian mathematics, and so on. So I was actually I started working on this topic when I was in Germany actually. मैं postdoc कर रहा था वहाँ जर्मनी में. कानपुर में मैंने PhD किया 2010 में. तो तब क्या हुआ कि 2009 में मेरे एक फ्रेंड ने मुझे बताया कि ये जो पाइथागोरस थ्योरम है इसको हमें शुल्ब सूत्रास में सेंचुरीज बिफोर पाइथागोरस उसमें डिस्क्राइब किया था. तो उस टाइम को तो मैंने उसको पूरा डिसमिस कर दिया. मुझे लगा कि ये तो पूरा हिंदू राइट विंग प्रोपेगेंडा है, ऐसे ही हवा में बात कर रहा है. तो मैंने इसको सीरियसली नहीं लिया. तो फिर मैंने PhD खत्म किया. फिर जर्मनी में आई वेंट टू परस्यू माय पोस्टडॉक, और वहाँ पे आफ्टर सम 2011-12 और सो मैंने एक आर्टिकल पढ़ी बाय एक स्कॉटिश मैथमेटिशियन द्वारा. उसका नाम था जॉन प्लेफेयर. वो उसने 1798 के आसपास उसने ये आर्टिकल लिखा था. इसमें ही उसने कोई एस्ट्रोनॉमिकल टेबल्स, खगोल शास्त्र के टेबल्स उसने एनालाइज किए थे फ्रॉम द इंडियन सबकॉन्टिनेंट. तो उसने देखा कि while predicting eclipses, जो इंडियन स्लोप थे, they were using the so-called Pythagoras theorem in their calculations. तो and this was much before Pythagoras. तो मैं इसमें बहुत सरप्राइज हो गया कि ये कैसे हो सकता है. Like John Playfair is of course he is not a Hindu nationalist, he is anything but that. So I thought okay, this is very strange. How many other things have I taken it dismissed as being Hindu nationalist right wing propaganda. तो इससे मेरा इस सब्जेक्ट में बहुत इंटरेस्ट बढ़ना शुरू हो गया. एंड और मैंने काफ़ी रिसर्च आर्टिकल्स पढ़ने शुरू किए, पुस्तकें पढ़नी शुरू किए मैंने. और मुझे बहुत सरप्राइज हुआ कि ओह इतना सारा डेप्थ है इंडियन सिविलाइजेशन में, इतना सारा मैथमेटिक्स का हेरिटेज है. आई मीन मैथमेटिक्स, नॉट जस्ट मैथमेटिक्स, ऑल्सो अदर फील्ड्स लाइक मेडिसिन एंड मेटालर्जी एंड ऑल दोस थिंग्स. बट लेकिन मेरा मैथमेटिक्स में स्पेसिफिकली इंटरेस्ट था बिकॉज ऑफ माई फिजिक्स बैकग्राउंड. So my mathematics I was focusing more and more on in my researches. So I was really surprised how much things are known and how much things were known to them and how little we as Indians we were taught about that in school. And this was for a big surprise and a big shock for me. So yeah, like for example, can you just tell any concepts which you know of which have come from India? I would like to hear from you. Like for example, like we know that zero comes from India. Any other concepts that you may be aware of? अच्छा, मेरा प्रश्न है कि जैसे कि हमें सब पता है कि जो जीरो शून्य का कंसेप्ट है वो इंडिया से आया है, भारत से आया है, हिंदू सभ्यता से आया है. तो जस्ट लाइक जीरो और कोई कंसेप्ट, बहुत सारे कंसेप्ट है. आपको किसी इस कंसेप्ट के बारे में जानकारी है जो कि एक्चुअली इंडिया से आई है? Sorry? Pi, yes. Pi is actually like, it was researched a lot in India, exactly. तो इसमें आर्यभट्टा ने 3.1416 की वैल्यू दी थी, जो कि बहुत ही एक्यूरेट वैल्यू थी उस टाइम पे। और उसके बाद केरला मैथमेटिशियंस ने उस पर इनफाइनाइट सीरीज का डिस्कवरी किया 14th सेंचुरी के आसपास, जिसको हम ग्रेगोरी लाइबनिज सीरीज किया कहते हैं, या फिर तो उससे यू कैन get pi to any number of decimal places. Okay, good. Any other things? Sorry? Yeah, decimal system. Yes, exactly. So that is actually very closely related to zero and the so-called, I would say it's the place value system. Right, exactly. Yeah, yeah. Okay. So there are actually many such concepts which have come from India. So for example, the binary number system, which we use in computers, the binary number system. It may come as a surprise to you that this was also developed in India in a totally different context. In the context of prosody, like poetic meters. जो संस्कृत में जो श्लोक बोलते हैं, उसके meters होते हैं, छंद होते हैं, छंद. तो उस context में by Pingala it was described in the context of the chandas, poetic meters. So this is, of course, I will not be able to go into detail how he came across all that, but and then I would also say some other concepts like the Fibonacci numbers, जिसे हम कहते हैं. This also actually came from India. So from the works of Pingala and then his commentators on his works like Halayudha and Hemachandra, they describe the so-called this Fibonacci sequence. Yeah. Right. So. Yeah, so these are some of the things which I was really surprised. These things all came from India, but why is it we always keep crediting the people like Fibonacci or like let's say Pythagoras, for example. Like even the Pythagoras theorem, the so-called Pythagoras theorem, is described in the Silva Sutras. So so these are, I thought why is it like so many things are described in the Indian civilization? They are all attributed to the West, and in the Western narrative of mathematics is all Greek. It comes from Greece and Europe. And why is it that the actual civilizational achievements are not known to us as Indians? So this was also a very important factor for me. So मैंने इसे भी बहुत okay. So, okay. So, all right. One other important thing which I also found very relevant was कि हम जब mathematics की बात करते हैं, हम जब mathematics की discussion करते हैं, most of the history books में maths is considered as a separate subject. As it's not. But the truth is, as if it has no connection to the civilizational background. Okay, if you look at, if there is any discussion of Indian mathematics, so it is all in the context of the Western framework. Okay, like Western language, Western terminology. Whereas in the Indian subcontinent, mathematics arose in a very close connection with the spiritual and religious framework of the Indian subcontinent, right? जिसको हम हिंदू फिलोसफी कह सकते हैं, हिंदू वर्ल्ड व्यू कह सकते हैं, which is like very different from that of the Western world view. So in the Western world view, is basically a materialistic world view in which all the things that you see around us come from matter. So everything is matter, like even your emotions, consciousness, even your awareness also comes from matter. Implicit assumption in the Western world view. Okay. Whereas Indian worldview there is this. It's not that. It's like the consciousness which we call in English. That is the fundamental thing or constituent of the universe. That is the fundamental constituent even of matter. So this leads to very deep differences. This is reflected also in the knowledge system. Okay. So like in the West, when you speak about spiritual knowledge, it becomes just a religion basically, and knowledge of science becomes basically physical sciences, basically material sciences, and which comes just from matter, and that's it. There is no scope for the Atman or the soul or those kind of concepts. Whereas in the Indian context, both these aspects are both sides of knowledge itself. one does not come at the cost of the other. So, like if you are, like you don't have to do like adhyatmik vidya, adhyatmik gyan at the cost of material knowledge, and vice versa. You don't have to do follow material knowledge at the cost of spiritual knowledge. So both these aspects are in fact integrated in the Indian system, which is like called by the name of Paravidya or Aparavidya. Aparavidya is the knowledge of the universe, a physical universe, whereas Paravidya is the knowledge of the soul, Atman, those kind of things. So that means there is no artificial distinction between these two things, whereas in the West they are kept really separate, and you have to follow one at the cost of the other. So these are some of the things which struck me in my studies, and which is also reflected in the way knowledge is formulated in these two systems. Okay, I honestly say it's a bit strange for me to keep on talking. Okay, I don't have slides right now. Maybe you can also just ask me questions. If you just go ahead and ask me any questions.
Any students, कोई स्टूडेंट ने कोई प्रश्न? सर ना टॉपिक खबर पड़ी आपने? Yes or no? Frankly, हाथ ऊपर करो, खबर पड़ी हो तो ना पड़ी हो तो I will explain. How many students, कितने स्टूडेंट्स को पता चला कि सर कौन से टॉपिक पे आज बात करने वाले? मेरा गला थोड़ा खराब है, so please bear with that. Yes. Very good, very good. Mathematics of ancient India. See, in this institute we have eminent expert and mathematics teachers, professors with us. એટલે એમની સામે કઈ મારે કહેવું એ તો બહુ નાની વાત કહેવાય. I am basically mechanical engineer, but maths અને પારસ ઉચાટ સર મને ભણાવતા હતા. I still remember, sir. I was in LDRP studying in just અહીં તમારા કેમ્પસની બાજુમાં. So, you are from which standard? 12th science. So, how do you consider maths? Is it difficult subject to study or? What? Remembering equations are difficult, sir. So, can you guide in that particular thing?
Yeah, I think maybe it's like once you get the basic concepts right, then you don't have to you can just remember. You don't have to remember. You can simply derive the equations very fast. So you just have to remember a few basic things, right? So if you, for example, have a problem in remembering the cosine formula, like sine of x plus y, sine x cos y plus cos x sine y. Yeah, sorry. And the values also. Yeah. So this is something this one basic formula you can remember maybe, but after that you can remember everything else. So sine of x plus 90 degrees is what you can just use this formula. So and you can sine of x minus 90 degrees, just that all these kind of things you can do. I mean you just have to remember some of the basic unifying principles, and on the basis of this you will be able to just remember all the other things. But at the same time, it is inevitable. You have to remember a few things for sure, because you cannot derive everything, on the exam, right? Yeah. And I think if you just keep on practicing problems, if you just keep on working with the concepts, practicing problems, then you use the formula so many times that you just remember them at some point. I would say practice. That's the best thing. Yeah, I think mathematics is like sports. The more you practice, the better you get. Right.
Any other question from math student?
I can partly add to that.
Yeah, please, sir.
Yeah, it's working. You see, once I read that what do the mathematicians do? They make patterns. We are all familiar with patterns. There are some designs you make, rangolis or something. It's a pattern, geometrical pattern. Okay. Now what happens is that, so now if you just generalize the definition of patterns, Then what happens is, I will say now, for example, a poet. What does a poet do? He writes a poem, right? It's also a pattern. It's a pattern of ideas. Okay. So now it's a thought. Similarly, mathematicians also make patterns. They do patterns, you see, develop patterns. And then what happens is that, so these are, why these patterns? So that is because they try to organize, their knowledge, new thoughts, or even the projections of future. And what happens is that, so why these patterns are important. If you write something, it remains with you for some time, okay. After all, paper, you are going to lose it sometime. It's going to destroy it. But then now, for example, a thought, that will remain much longer. And ideas, they always remain much longer. So if you put it in the form of mathematics, that mathematical pattern will remain for much, much, much longer, almost forever. So mathematics is nothing but making patterns, developing patterns of the different ideas and then putting them into action. So I think when you realize, now you think, whenever you learn mathematics, it's from this point of view. Your equations, whether it is a binomial equations or now a cubic equation, it's a pattern basically. You can learn about now sequences and permutations, combinations. These are all patterns. So that's one thing I wanted to tell you. And today Bhaskar, Dr. Bhaskar, he is going to tell you something about this. And Dr. Srinivasa Ramanujan, whose contributions we are trying to now celebrate today, his contribution to the field of mathematics. So it's a National Mathematics Day. Well, he also different, or his ideas, he put them into form of patterns. What he discovered of those patterns, you see. Only thing is, how did he do it? Perhaps he alone did. Nobody else knew it. But while because he was such a genius, Ramanujan was such a genius, that his ideas, now he would come and with a flash, he would write down this entire formula. And formula is a pattern. Remember that. So recently, we all had been to his hometown, Kumbakonam. It's said to be a city of temples. There are about, more than 20-25 temples there, all beautiful. And there is one temple called Sharangapani, huge temple, in front of which he had his house. We saw it, but the point is that that house is now, it's such a small, it's a very modest kind of house. And then it's now a memorial, but we really enjoyed it. So I'm really glad that Dr. Bhaskar is here, and we are celebrating his National Mathematics Day. And he's going to tell you about his contribution. Maybe he'll also touch upon some of his work also, I believe. And but mainly he will talk to you about what all has been done in our country. Only thing is that, there are many things. Whenever something new happens, whenever some new discovery takes place, we are always ready to say that, okay, it always existed in our country. Okay, we are always ready. That discovery, that particular now invention, we already had, in our Vedas also like this, not like that. Well, if it were like that, now we should try to bring it forth. It's our job to do it. And that's precisely what Dr. Bhaskar has done. He has tried to bring it out. One book he has written, The Imperishable Seed. Because mathematics is a seed, He's taken this title from Bhagavad Gita. Mathematics is a seed from which everything, the entire universe has grown, following certain mathematical patterns. Okay, that's very important. And then he's going to tell us about this seed, how this seed has grown into a huge tree and continues to grow. Okay, I think I have given him a sufficient introduction for Bhaskar, and then I think he can take over. Lakshmi. It's not very eager. Okay, are they coming now? Okay, okay, take 2 minutes. Fill up 2 minutes. No, no, leave it, you side it there.
कौन रिजल्ट के लिए
So we'll proceed the formal inaugural first once we have the authorities with us, and then the official talk of the sir will be delivered. Right? समझ में आ रहा है आपको? It is for you, right? He has tried a lot to prepare it also maybe, right? So we have our guest with us. So I request Saucer and other members to join us on the dais. अच्छा, तो नहीं अभी आप लोग inaugural तो कर Please have a seat. बट सर फोटो में फिर वो ब्लैंक लगेगा, सो इसे फिर कंप्लीट Very good afternoon to all of you. Very good afternoon, one and all, as we are waiting since long time. So now we welcome our guests, Dr. Vineet Kamble sir and Bhaskar Kamble sir, with huge round of applause. I, Dr. Sangeeta Rathore, on behalf of GUJCOST, welcome you all on this National Mathematics Day celebration. This program is a collaborative program with NCSTC and IITE Gandhinagar. Today is a great day. On this day, a great scientist, Indian mathematician genius, Srinivasa Ramanujan was born. This year,
is celebrating 136th birth anniversary of Srinivasa Ramanujan. This day is an occasion to remember Srinivasa Ramanujan's great achievements and reflects on the significance of maths in our daily lives. He is considered as one of the world's greatest ever mathematicians, proving over 3,000 theorems. In order to inspire the life and his golden achievements to the younger generation, the Government of India has announced 22nd December as National Mathematics Day since 2012. So, GUJCOST has planned various activities for week-long day celebration on LMD, and this program is being organized as regional science centers and community science centers as well. So I would like to invite Dr. Poonam Bhargava ma'am for welcome address.
Thank you, and a very good afternoon to one and all. Respected Kamble sir, Bhaskar sir, respected Sahu sir, the faculty from IIT and all the students and faculties who have joined us here today on this auspicious occasion for the celebration of National Mathematics Day. So today it's a very important day actually, which will take you to, you know, you will feel the power of mathematics that our country has had and has given to the world. And for this, I am actually should thank and welcome IITE, Dr. Harshad Patel and Dr. H.C. Patel sir, who actually never refused to give the occasion and time to host such kind of programs. So with this, I actually welcome all of you. And mathematics is actually a very difficult subject for most of us. It may be good, it may be interesting, it is interesting, but most of us think that, you know, mathematics is very difficult. But mathematics is everywhere. Everywhere, wherever you look, you will find mathematics over there. You people are still sitting, how many are sitting? You are standing height-wise, so how are you standing like that? So everything, you know, if you start to enjoy numbers, then of course you will have everything you can, you know, weigh in numbers itself. So and today of course Dr. Bhaskar Kamble sir is here with us, and he has given us time, his valuable time, and he is one of the best person to, you know, take you to enjoy mathematics rather than be afraid of mathematics. So I welcome you sir, and look forward to a very inspiring session. Thank you.
Thank you, ma'am. Now it's time for lighting of lamp. So I would like to invite all the dignitaries. Please join for inaugural of our program, National Mathematics Day for Maths for Vikshit Bharat. Now, it's time for floral welcome of our dignitaries. I would like to invite Northern Sahu sir to felicitate Dr. Bhaskar Kamble sir with floral bouquet. Now, I would like to request Poonam Bhargava ma'am to felicitate Dr. Vinod Kamble sir. Now, I would like to request Jhalak to felicitate Dr. Narottam Sahu sir. I would like to request Ms. Devangi to felicitate Dr. Poonam Bhargava ma'am. I take this opportunity to invite Dr. Narottam Sahu sir for opening remarks on National Mathematics Day.
Good afternoon to everybody. Namaskar. Actually, we would like to request for your excuse. We have a little bit delay in arranging this program. Thanks for your patience. Respected Dr. B.B. Kamble sir, Madam, and our very dear Dr. Bhaskar, and the faculties of IIT, all the students, all the teachers, and all our project directors, project coordinators of regional science centers, and district community science centers, and all the other institutions who is participating in this program through our GUJCOST live streaming. On behalf of Gujarat Council on Science and Technology, Department of Science and Technology, Government of Gujarat, and the Institution of Teacher Education, Indian Institution of Teacher Education, IIT Gandhinagar, we welcome all of you this National Mathematics Celebration Day. It is a very auspicious day. Since 2012, we are celebrating it in a very lots of programs and activities. And इस दिन का पीछे क्या है इसके बारे में हम लोगों का एक छोटा सा मूवी है वो दिखाना है. How this Srinivasa Ramanujan is a very young person who has done a lot of things on mathematics on his own with lots of struggle. Okay, and he finally reached at the peak, and when we were supposed to work out lots of new solutions, new methodology, new fruits of that his programs, activities, very unfortunately he passed away. Only at the age of 30, and this was about last 26 April 1920 से. So after that, this government of India and lot of our Indian mathematicians and all our educators, they thought that if Srinivasa Ramanujan has done that much of theory and this type of mathematics solutions at this age of 30, and if he can be there with us for another 20 years, 30 years, then how best we can excel in mathematics, okay, for this country, for this our people, or for the planet, everybody. So with that inspiration, how mathematics can be our day-to-day practice, how we have to achieve all this success through lots of difficulties by following or by going through the life and the struggle of Srinivasa Ramanujan. Just to inspire that, Government of India in 2012-11, they have announced this birth anniversary of Ramanujan, that is 22nd December, to be celebrated as Indian National Mathematics Day, and it was started from 2012. So 10-11 साल हो गया हम लोग इनको सेलिब्रेट कर रहे हैं, अलग अलग थीम में, अलग अलग प्रोग्राम में, अलग अलग एक्टिविटीज में. आई रिमेम्बर जब 2020 हमारा इस प्रोग्राम था, that time we were stuck with this corona, COVID-19, and that time we could find to have a best mathematician for this program. That is Dr. Bhaskar Kamble. That time he was in Berlin, and we are here, and we are covered through Corona, COVID-19, and we have that tool of this networking. So that time it was I think 1 hour program or something like that, and it went on so smoothly and so interestingly, so excitingly. We got lots of good feedback from all the participant teachers who were attended that time. And this time when we are planning for this program, we came to know that Dr. Bhaskar is around India. He has come to here to spare some of his time. So we requested Dr. Kamble sir as well as Dr. Bhaskar to carve out some of the time on this specific day, auspicious day, so that we can have some sort of good discussions, good direction, good mentoring from Dr. Bhaskar. He is IIT Kanpur alumni. He is doing an excellent job in mathematics, particularly in the data scientist in Berlin, and he is also, like our faculty, he is teaching, he is researching, he is writing, and lot of things. And I think when he will be talked with us, then I think we can learn much more about him and his work. And with this also we have planned this program is a week-long program. So all the district science center, regional science center, even our science city has lots of new programs, new activities, 7 days. Okay, and this program we have patronized with a National Council for Science and Technology, Communication, NCSTC, Department of Science and Technology, Government of India, and we promise that through this program, we'll have at least 1 lakh delegates, students, teachers, those who can participate. They can give actively participate, take a message that how mathematics is interesting to them, how best they can use mathematics, how best we can have this number. जब हमारे पास आंकड़ा था, now this आंकड़ा is now become data. और विकसित भारत it is data. हमारे पास कितना डाटा है, कितना बच्चे हमारा क्लास 9 में पढ़ाई करते हैं, कितने बच्चे को हम लोगों को अटल टिंकरिंग लैब में हम लोग इनको काम करने के लिए मौका दिया, कितने बच्चे इसमें कुछ नया प्रोजेक्ट बना करके स्टार्टअप के साथ जुड़ होता है. ये सारा मैथमेटिकल जो नंबर है, नाउ इट इज कन्वर्टेड टू डाटा, एंड हाउ दिस डाटा कैन बी कन्वर्टेड टू अनदर प्रोजेक्ट. दैट्स द गेम ऑफ द टाइम ऑफ नाउ. ओके, so everything, every project, every proposal, whenever we are discussing about things, whether it is money, whether it is beneficiary, whether it is implementation time, whether it is any type of program constraint, whatever things, everybody is asking for a number. If there is a number, you will be a good presenter. Your presentation skill is good. You are convincing this thing. If you don't have number, nobody understands you. How best you are. So we welcome our registrar of this very beautiful university, IIT, Sri S.C. Patel sir, to grace as our guest of honor for this program, special program. And sir, we have just started this, initiated this program because students and other students are joined in live stream. Please have a seat. And we have this day, and I was talking about how important is teaching mathematics to the students, and how that concept of Ankara is now converted to data, and this data is now taking the step in our Vikshit Bharat. So with this word, we have the very eminent faculty, Dr. Bhaskar Kamble. He's a very young, dynamic, good writer, good author, good speaker, and also good orator. So you can see that we can say that next half an hour, 40 hours, he will be taking us to the Hindu mathematics, where our mathematics was the centers of attraction for everybody. Starting from 0 to infinity, we traveled a lot in this, and we have to go. So with this word, I once again welcome Dr. B.B. Kamble sir, Madam Kamble, Dr. Bhaskar, and all our Dr. H.C. Patel sir, Registrar IIT Gandhinagar, my colleagues from GUJCOST, all the faculties from IIT, all our teachers, all our students, all our participants and project directors, coordinators, science communicators who are participating in this program. And this is the opening program of this 7 days mathematics day week program. And every day we will be having lots of new program activities and we will be in touch. आप लोग देखिए डाटा का पावर कितना होता है, how you convert this आंकड़ा to a new way of activities. Okay, with this word, I thank you for your kind participation. I look forward for your 7 days and not 7 days में mathematics खत्म नहीं होगा. It is not like a crash course or a certificate course. It is a initiative. It's just like fueling your thoughts and imagination. इसी को लेकर के हम लोग बोर्ड एग्जामिनेशन में हम लोगों को अच्छा इंफॉर्मेशन नंबर लाएंगे, हमारा एंट्रेंस में लाएंगे, हमारा प्रोग्राम में लाएंगे, प्रोजेक्ट में लाएंगे एंड हमारा सोसाइटी में भी लाएंगे. तो ऐसे करेंगे तो जो हमारा ऑनरेबल प्राइम मिनिस्टर सर का जो कैंपेन है विकसित भारत के लिए, डेवलपिंग कंट्री के लिए, अभी हम लोग जस्ट एक प्रोग्राम खत्म करके आया. तो इंडिया इंटरनेशनल साइंस फेस्टिवल का अभी नेक्स्ट मंथ में होगा. इसमें भी एक आज का दिन में हमारा उनके कर्टन राइजर प्रोग्राम था. इसमें भी हम लोगों को वही बताया कि हाउ स्टूडेंट्स हैव टू टेक दिस प्रोग्राम एक्टिविटीज एंड बी प्रिपेयर्ड फॉर टू वेलकम आवर 2047 जब हमारा आज़ादी का 100 साल हो जाएगा. तो ये अमृत काल जो टाइम एंड जो संज्ञा दिया गया है, डेफिनेशन दिया है ऑनरेबल पीएम, इससे हम लोगों को कैसे हम लोगों को जोड़ पाएंगे. सपोज आज का जो देखो फिर आंकड़ा का कैसे होते हैं, आप कैसे इनको कोरिलेट कर सकते हैं. सपोज हमारे पास कोई 10 ईयर का स्टूडेंट है आज, ओके, 24 साल के अंदर में इसको 34 साल हो जाएगा, 34 ईयर्स हो जाएगा. एट द एज ऑफ 34 ही और सी विल बी ए वेरी कंसर्न सिटीजन. ओके, तो हमारी जैसे अभी वो आकर के इसी स्टेज में बात करेंगे और काफ़ी प्रोजेक्ट को लीड करेंगे, काफ़ी नया रिसर्च करेंगे, काफ़ी ही और सी माइट बी ए मिनिस्टर, एक सेक्रेटरी, कुछ भी होगा गवर्नेंस में. ओके, तो कैसे ये सिचुएशन को लेकर के 24 ईयर के बाद जब 2047 होगा उस टाइम में कैसे हम लोग कर सकते हैं. तो ये सारा चीज़ का जो है पीएम साहब का जो अमृत काल है, ये अमृत काल में ये डाटा को लेकर के, नंबर को लेकर के, मैथमेटिक्स को लेकर के, साइंस, इंजीनियरिंग, टेक्नोलॉजी को लेकर के कैसे कर सकते हैं ये देखेंगे. एंड इसी के लिए हमारा गुजकोस्ट जो है जीएसटी के अंदर में काम करते हैं. हम लोग को काफ़ी प्रोग्राम में इसको लगाते हैं, लगा करके रखते हैं बच्चों को. हमारे जो गुजरात स्टेम क्विज है इसमें 5 लाख से ज़्यादा बच्चे पार्टिसिपेट करते हैं. इस साल में हम लोग नेक्स्ट मंथ में इनको अनाउंस करेंगे. इनका नेक्स्ट एडिशन में हम लोग चाहते हैं कि 5 लाख से 10 लाख हो जाएंगे. 2 करोड़ रुपीज़ का हम लोग इनाम देते हैं. एंड हम लोग को कहाँ तक ले जाते हैं आप सोच भी नहीं सकते. भाभा एटॉमिक रिसर्च सेंटर का पूरा जो न्यूक्लियर रिएक्टर से शुरू करके डीआरडीओ का बैटल फील्ड से शुरू करके हम लोग अभी इस टाइम में हम लोग देश का बाहर जाने के लिए भी प्लान कर रहे हैं. इफ यू वर्क with that mission, so you can be at the NASA station sometimes next year. Okay, so lots of things is going on, robotic computation, ये सारा चीज जा रहे हैं साइंस, मैथमेटिक्स, इंजीनियरिंग एंड टेक्नोलॉजी को बढ़ावा देने के लिए. एंड वी आर वेरी फॉर्चुनेट टू हैव दिस IIT and our special thanks to Honorable Vice Chancellor Dr. Harshad Patel sir for his kind and generous support for this program, this type of program. ये प्रोग्राम के लिए सर हम लोग नॉट ओनली वी आर कंसंट्रेटेड इन गांधीनगर, अहमदाबाद, एंटायर कंट्री इज वाचिंग दिस प्रोग्राम. तो मैसेज इज हैज गॉन टू बोथ CMO, PMO, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, एवरीथिंग. इन फैक्ट आवर IY इंटरनेशनल ईयर ऑफ बेसिक साइंस फॉर सस्टेनेबल डेवलपमेंट सारा तक जा रहे हैं कि हाउ IIT ये पार्टनर ऑफ चेंज, हाउ IIT इज चेंजिंग द यंग माइंड्स, हाउ IIT इज डिलीवरिंग द न्यू इकोसिस्टम for the young researcher. We are very much thankful to you, and my special thanks and regards to Dr. H.C. Patel sir, Registrar IIT, for his kind time. He was also very busy in the meeting. Thank you so much for sparing some of the time. We have wonderful guests, and I think we have right now our guest from UP Council for Science and Technology. Give a big hand. And we thankful to you, your gracious presence. And you can see that how our science National Mathematics Day is celebrated with a very glamorous and very eminent speaker like Dr. Bhaskar Kamble, who is an IIT Kanpur alumni and presently working at Berlin University as a data scientist and researcher, and he will be guiding our teams also. And this program is also going live. All our community science centers, district science centers, regional science centers, science city, all are participating. And this program will continue to days, and at least 1 lakh student minimum will have, they will be participating and directly getting the benefit from this thing. And in the student participation, their schools and their campus is also open to them. So thank you everyone. We hope that mathematics, we have to take this mathematics as a part of our daily life. We'll talk in terms of mathematics right now. No subjective remark or something. Okay. So ये सब को लेकर के we'll be having some sort of a new initiative, new inspiration for this 2047. Thank you.
Thank you so much, sir. Such a nice talk and brief address. So now I would like to request Dr. H.C. Patel, sir. He is Registrar, IIT Gandhinagar. Now, I take this opportunity to invite Dr. Narottam Sahu sir to felicitate Dr. H.C. Patel sir. Now, I would like to request Dr. He is Registrar at IIT Gandhinagar for brief address.
Dr. Narottam Sahu sir. We have Kamble Square, Dr. Kamble Square, and PSO, Principal Scientific Officer, Gay Scientific Department also. Namaskar to all. Today it is best occasion that we are celebrating this National Mathematics Day in perspective of Vikshit Bharat. एक छोटी सी चीज अभी मेरे ध्यान में आई कुछ दिन पहले, जैसे धनलक्ष्मी वो धनतेरस के दिन अपने जाते हैं कुछ न कुछ ज्वेलरी लेने के लिए, तो आई वेंट देयर एंड माय सन इज इन कनाडा, तो हम शॉपिंग के लिए गए थे, तो हम सोच रहे थे कि वो उसका पेमेंट वो कनाडा से कर देगा। अभी आप लोग भी करते हैं वो क्यूआर कोड स्कैन करके पेमेंट करते हैं ना, कितने बच्चे करते हैं क्यूआर कोड से पेमेंट या कर पाते हैं या जानते हैं, शायद किसी के पास अथॉरिटी ना हो पर सब जानते तो है। कितना इजी है, बहुत इजी है ना, जस्ट जाके स्कैन करो, अमाउंट डालो, हो गया, राइट। तो बस यही मेथड इम्प्लीमेंट करने का हम सोच रहे थे। अब ज्वेलरी ले रहे हैं तो छोटा मोटा स्टोर भी नहीं था, बहुत बड़ा ही स्टोर था, और फिर हमने बेटे को बोला वो क्यूआर कोड फोटो डाल के उसको व्हाट्सएप में भेजा कि इसको इसमें पेमेंट डालो। तो अब जाके पता चला कि कनाडा में अभी तक यूपीआई पेमेंट ही नहीं है, और हम लोग इतना आगे हैं कि हम बहुत इजीली यूपीआई पेमेंट कर पा रहे हैं। तब सोचिए कि 2047 में जो मोदी सर ने कहा है हम कितना आगे जा सकते हैं, राइट। इसका पॉजिटिव नेगेटिव क्या है वो पता नहीं है, क्योंकि मैंने अभी रविशंकर मंत्री जी जो हमारे हैं आईटी मिनिस्टर, उनका एक सेशन भी सुना था 1-2 दिन में ही, कि 20 सेकंड में कोई भी मोबाइल हैक कर सकता है। तो 1 घंटे का सेशन था, वो भी बहुत इंटरेस्टिंग था। आप लोगों को भी देखना चाहिए, आप YouTube पे जाके सर्च कर सकते हैं। अभी ऐसी कौन सी सिचुएशन आ जाती है जब 20 सेकंड में हमारा मोबाइल हैक हो सकता है। जब बहुत सारों को ऐसा भी होगा, यार मोबाइल हैक कर लिया, ये क्या कर लेगा, क्या इसमें क्या हो सकता है। पर जिन लोगों का लाइफ मोबाइल से चलता है, फाइनेंशियली, एडमिनिस्ट्रेटिव, मतलब ऑफिस वर्क, तो उन लोगों को परेशानी हो सकती है। बहुत सारे लोगों का पर्सनल डेटा भी रहता है, तो उनको भी परेशानी हो सकती है। अच्छा, एक बात बताओ, जैसे हम अपना कोई भी मकान, हमारे इंडिया में ऐसा है कि बाहर एक नेम प्लेट लगाते हैं, डॉक्टर H.C. पटेल प्लेट, मतलब घर का नंबर ये है वो है। अरे मैंने नहीं लगाया, क्योंकि मैं हमेशा सोचता हूँ यार कोई भी थर्ड पार्टी आएगा, उसको नाम पता चलेगा तो सीधा नाम लेके घुस सकता है। अच्छा पटेल साहब है, तो जो घर वाले हैं उनको लगेगा यार कोई जान पहचाना लगता है तो सीधा एंट्री दे देगा। तो अब ये तो सिर्फ डेटा है जो हम घर के बाहर लगाते हैं, पर लोग उसका मिसयूज किस तरह से कर सकते हैं। मैं अभी तो आप बहुत छोटे हैं, पर धीरे धीरे आपको भी रियलाइज होगा। कोई भी ऐसा पूछेगा भाई आपके पापा कैसे हैं, मजे में हैं, तो आपको लगेगा यार अंकल को जानते हैं, पर वो अंकल है कि नहीं वो भी पता नहीं। तो ये अपना मोबाइल का डेटा अगर किसी और के हाथ में जा सकता है, तो वो भी ऐसा ही कुछ गड़बड़ी कर सकता है। तो उसके ऊपर एक बहुत बढ़िया सेशन है, वो भी आप टाइम निकाल के देखिएगा। अच्छा, मैथ्स क्या है, तो एक सिंपल कंपैरिजन करें कि ऑक्सीजन क्या है। कहीं दिखता है? दिखता कहीं नहीं है। पर अगर ऑक्सीजन नहीं है तो सब खेल खत्म, राइट? ऐसा ही है ना ऑक्सीजन के लिए तो। और हमने कोरोना में सीखा भी, दिखता नहीं था फिर भी लोग ढूंढ रहे थे कि ऑक्सीजन कहाँ है। तो मैथ्स इज अ लैंग्वेज ऑफ दिस इंजीनियरिंग एंड टेक्नोलॉजी। मतलब अगर उसमें मैथ्स नहीं है तो इसके बहुत प्रॉब्लम हो जाएगी। वो लैंग्वेज है, आप एक्सप्लेन नहीं कर पाओगे कि भी करना क्या है, राइट? सो कंसीडर मैथ्स एज अ लैंग्वेज। अच्छा, ये क्या होता है, मैथ्स की बुक देख के बच्चे बहुत परेशान हो जाते हैं, दुखी हो जाते हैं। अच्छा, क्यों ऐसा होता है, किसी को पता है? उसमें प्रॉब्लम बहुत रहते हैं। क्योंकि मैथ्स की बुक ही होती है प्रॉब्लम की, तो उसको देख के बच्चे परेशान, यार दुखी हो जाते हैं, यार बहुत प्रॉब्लम है इसमें। ये तो लाइटर टोन था, बट सही मायने में अगर आपको कुछ भी एकेडमिकली स्ट्रॉन्ग करना है, आपको मैथ्स करना ही पड़ेगा। अब मैथ्स को अवॉइड करके आगे जा पाओगे, ऐसी सिचुएशंस बहुत ही कम आती है साइंस एंड टेक्नोलॉजी में। मैं मैथ्स टीचर रहा हूँ, एलडी इंजीनियरिंग कॉलेज में मैथ्स का प्रोफेसर था। पर मैंने महसूस किया कि जो लोग आईआईटी एनआईटी में दूसरे सब्जेक्ट के, जैसे सर फिजिक्स के हैं, ऐसे इंजीनियरिंग के, तो उनको मैथ्स मेरे से ज्यादा आता है, क्योंकि वो एक्चुअली इम्प्लीमेंट करते हैं। मैं क्या जानता हूँ कि भाई हाउ टू फाइंड द लेंथ ऑफ दिस कर्वेचर पोर्शन, मतलब हम मैथमेटिकली उसको थियोरेटिकली देखते हैं और ऐसे ही बच्चों को पढ़ाते हैं। जो टेक्नोलॉजी में है वो लोग क्या करते हैं, उसका यूज करते हैं, और जो यूज करते हैं उनकी जानकारी थियोरेटिकल से थोड़ी ज्यादा रहती है। सही बोल रहा हूँ सर?
Indian mathematicians के साथ भी ऐसे ही था actually.
Yes.
They were very, सब subjects पे they were utilizing mathematics. Yeah.
So keep in mind, you need to learn maths and you need to use maths. जब मेरा नीचे बहुत ज़्यादा ज़रूरत है तो मैं यहाँ पे मेरी स्पीच ख़त्म कर रहा हूँ और मैं साहु सर से फिर से थैंक यू बोलता हूँ, प्रोवाइडिंग मी दिस स्टेज। थैंक यू सर, थैंक यू।
Thank you so much, sir. Such a nice words, and you said maths considered as a language. Thank you so much, sir, for joining us. Now, I would like to request all dignitaries to take your seat of the dais. now we will play a screening of movie on maths. A movie is one based on biography, a self-taught mathematician. Now, second movie is based on the Man Who Knew Infinity.
What do you see?
Sand.
Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything.
Influence series. I've never seen anything like them. From an Indian clerk, ill-educated in Madras, I would very highly value any advice you give me.
That's for you. Postmarked England.
Yours truly, S. Ramanujan.
What does the S stand for?
Not himself.
You intend to invite him here.
Do not forget me. I could never.
Are you Ramanujan by chance? Oh. Don't be intimidated. Great knowledge comes from the humblest of origins.
For the good of everybody, you should attend some lectures.
I'm here to publish, but that only contain a small sampling of my discoveries.
This will take a lifetime.
Maybe two.
We need proofs of your work.
But they are right, sir. I haven't completed that proof. How do you know? I just do.
You don't pull a stunt like that in my class.
Get out!
How do you know that theorem?
Give it to me. These steps you want, they do not know how to do. Where do you think you're going? This is our home. Don't you know what I've given up to be here? I have nothing. You wanted to know how I get my ideas? Go on, speak to me.
There are no proofs. We're just supposed to take him at his word? No, you're to take him at mine. Why do you do it?
Because I have to.
There are no proofs that can determine the outcome. Matters of the heart.
Now it's time for popular talk on maths for Vikshit Bharat. For this purpose, we have invited Dr. Bhaskar V. Kamble. First of all, I would like to introduce Dr. Bhaskar Kamble, sir. He is an author, theoretical physicist and data scientist. He obtained his PhD in theoretical condensed matter physics in 2010 from the IIT Kanpur, India. Thereafter, he worked as researcher for several years at Ruhr University, Bochum, Germany. The University of Germany at the Asia Pacific Center for Theoretical Physics in Pohang, South Korea, specializing in the field of unconditional superconductivity, quantum phase transition, and many particle physics. Now, he is currently working as a data scientist in Berlin. He is author of book with very impressive name, The Imperishable Seed. The book talks about how Hindu mathematics changed the world and why this history was erased. During the talk, he will speak about the history of mathematics in the Indian subcontinent and how it is closely related with Hindu religious, spiritual and philosophical thought. He will discuss about its transmission and impact on development of mathematics in the world. So, huge round of applause. We welcome, sir. Huge round of applause, sir. So, please come for talk. PDF. Over to you, sir.
Okay, thank you a lot. So finally we can begin with the talk. मैं एक्चुअली हिंदी में बात करूंगा मैं क्योंकि प्रैक्टिस कर पाऊंगा हिंदी में. क्योंकि मेरी हिंदी इतनी अच्छी नहीं है अभी. ये गुड अच्छा मौका है हिंदी में बात करने का. तो आपने अभी जो मूवी देखा रामानुजन का, तो आपने देखा होगा कि वो मतलब बहुत ही रिलीजियस एंड स्पिरिचुअल आदमी था. तो इसमें ये एक एक्चुअली इंडियन मैथमेटिक्स का बहुत ही स्पेसिफिक ट्रेडिशन रहा है कि जो मैथमेटिक्स इसमें जो हमारे हिंदू सभ्यता में थी, वो एक्चुअली जैसे कि वेस्ट में है साइंस और मैथमेटिक्स एक स्तर पे है और रिलीजन दूसरे स्तर पे है. तो अगर आप रिलीजन करते हो तो आप साइंटिफिक नहीं हो सकते, और अगर आप साइंस करते हो तो आप रिलीजियस नहीं हो सकते. तो और उसमें तो इंडियन सिचुएशन में ऐसा ये आर्टिफिशियल डिस्टिंक्शन नहीं है. नॉलेज का था, मतलब नॉलेज इज डिवाइडेड इनटू परा प्रकृति, परा विद्या एंड अपरा विद्या. सो जो हमारा जो फिजिकल नेचर है उसका जो स्टडी है, उस स्टडी को अपरा विद्या कहा जाता है, और जो आध्यात्मिक विद्या है, नॉलेज ऑफ द आत्मन, ब्रह्मन एक्सेट्रा गॉड, सो उसको परा विद्या कहा जाता है. और हमारी सभ्यता में लाइक आई टॉक अबाउट नॉट जस्ट हिंदूज, ऑल्सो बुद्धिस्ट और जैन्स, जो भी हमारे ट्रेडिशनल यहाँ पे स्ट्रीम्स ऑफ थॉट रहे हैं, उनमें ये डिस्टिंक्शन नहीं था. सो ये एक बहुत ही महत्वपूर्ण चीज़ है जो हमें याद रखनी चाहिए. तो ये मैंने कुछ बातें पहले बताई भी थी. और ओके, सो ओके, आई एम स्ट्रगलिंग नाउ विद दिस. PDF format. This was okay. Okay, thanks a lot. So I will now go. मैं भी start करूँगा इस अपने talk के साथ, व्याख्यान के साथ. तो अभी slides है नहीं, so scroll ही करना पड़ेगा through the slides. आपने मेरे बारे में बहुत सुना, तो मैंने यहाँ पे थोड़ा सा अपने बारे में इंफॉर्मेशन लिखा है. तो मैं फिर से इसको रिपीट नहीं करूँगा बस. और मैंने कुछ टाइम पहले बोला था कि 2009, 10, 12 के आसपास मैंने जो एक्सपीरियंस किया था पाइथागोरस थ्योरम के बारे में, वो अभी आपको मैंने वो कहानी सुनाई है. मैंने जैसे बाद में मैंने जॉन प्लेफेयर का आर्टिकल देखा और उससे मुझे वेकअप कॉल था मेरे लिए. इस तरह से मेरा इस विषय में मेरा आर्टिकल्स और पुस्तकें पढ़ी, और ये सब इंफॉर्मेशन मैंने इस पुस्तक में कलेक्ट किया है, द इम्पेरिशेबल सीड, हाउ हिंदू मैथमेटिक्स चेंज्ड द वर्ल्ड एंड व्हाई दिस हिस्ट्री वाज इरेज्ड, जो मेरे हाथ में यहाँ पे है. और मैं बस यही भी बोलना चाहूंगा कि इस पुस्तक को बहुत ही जाने माने लेखकों ने रिव्यू किया है और पढ़ा है, तो इट्स वेरी नाइस टू नो दैट. प्रोफेसर के रामासुब्रमण्यन है IIT बॉम्बे से, मैथमेटिक्स के प्रोफेसर MS श्रीराम, ही इज ऑल्सो वेरी वेल नोन हिस्टोरियन ऑफ मैथमेटिक्स. प्रोफेसर HC वर्मा, राजीव मल्होत्रा, देन प्रोफेसर सुभाष का जो कि कंप्यूटर साइंटिस्ट है ओक्लाहोमा स्टेट यूनिवर्सिटी में, और फाइनली प्रोफेसर रामामूर्ति जो बहुत वेल नोन साइंस एडमिनिस्ट्रेटर है और न्यूक्लियर फिजिसिस्ट रहे हैं. एक और चीज मैं बताना चाहूंगा कि ये मुझे बहुत प्रसन्नता होती है कि इस विषय के बारे में इंफॉर्मेशन वेस्ट पश्चिम में भी काफी फैल रही है. तो हाल ही में एक स्प्रिंगर ने एक किताब पब्लिश की थी हाइंस क्लाउस स्ट्रिक द्वारा. ये एक जर्मन राइटर ऑफ मैथमेटिक्स है. तो गशिक्शन ऑफ मैथमेटिक नाम है इस पुस्तक का. तो उसमें भी इन्होंने इस पुस्तक में मेरे किताब को रेफर किया है, Bhaskar Kamble, and he has talked about these two books of mine. So it's actually very heartening to know that this information is also becoming more well known in the West. So तो जब हम मैथमेटिक्स की हिस्ट्री के बारे में सोचते हैं, मैं एक संक्षेप में एक उसका वर्णन दूंगा, हमारी क्या मान्यता है मैथमेटिक्स हिस्ट्री के बारे में। तो जैसे कि ये है टाइम एक्सिस, हॉरिजॉन्टल लाइन है, ओके। तो इसमें सबसे पहले हमारे पास क्या था, ये एंशिएंट सिविलाइजेशन थे, जैसे कि बेबीलोनिया था और इजिप्ट था 4000 साल पहले, लाइक 2000 BC के टाइम पे। फिर इसमें थोड़ा सा दे हैड सम मैथमेटिकल नॉलेज इन दिस सिविलाइजेशंस। उसके बाद हमारे यहाँ था ग्रीक सभ्यता की शुरुआत हुई, ग्रीक करिश्मा, ग्रीक मिरेकल कहते हैं, जैसे कि मैथमेटिक्स इस ग्रीक सभ्यता में it developed miraculously by people like Pythagoras, Euclid, Archimedes. तो ये है, this is the second important step. फिर उसके बाद यूरोप में थोड़ा सा डार्क एजेस हुआ, क्रिश्चियनिटी का राइज हुआ, तो बर्निंग ऑफ विचेस एंड ऑल दिस काइंड ऑफ डार्क थिंग्स हैपेंड। तो इसमें कोई नॉलेज का डेवलपमेंट नहीं हुआ इस टाइम पे। और आफ्टर दिस शुरू हुआ लाइक सेंचुरीज में लियोनार्डो दा विंसी एंड ऑल दिस अदर आर्टिस्ट एक्सेट्रा। तो उन्होंने ग्रीक नॉलेज को रिवाइव किया एंड दिस वाज द यूरोपियन रेनेसांस। और फाइनली 17वीं सदी की शुरुआत से you had the birth of modern science with people like Galileo, Kepler, Newton. So and this is हमारी मान्यता ये है कि ये है साइंस और मैथमेटिक्स का इतिहास। और इनमें से अगर हम सबसे महत्वपूर्ण घटनाएं अगर इसमें हम रिटेन करेंगे तो इसमें है, तो वो ये रहेंगे बेसिकली ये ग्रीक करिश्मा और बर्थ ऑफ मॉडर्न साइंसेस 17th सेंचुरी ऑनवर्ड्स। तो इस पिक्चर में हमें ऐसा महसूस होता है कि मैथमेटिक्स एंड साइंस इज एन एक्सक्लूसिवली वेस्टर्न डेवलपमेंट, इसमें और किसी सिविलाइजेशन का कोई रोल नहीं रहा है। लेकिन इस पिक्चर में कोई डिटेल्स मिसिंग है, और मैंने इसको अगले स्लाइड पे दिखाया है, वो है यहाँ पे रेड में। सो यू सी लाइक मेनी ऑफ दिस थिंग्स, शुल्क सूत्रास, जिसमें कि सो कॉल्ड पाइथागोरस थ्योरम मेंशन्ड है, एंड बहुत सारे अदर दूसरे ज्योमेट्रिकल रिजल्ट्स भी है। फिर थिंग्स लाइक लिंग्विस्टिक्स, प्रोसोडी, छंद शास्त्र जिसे कहा जाता है, और इस कॉन्टेक्स्ट में बाइनरी नंबर्स, देन सो कॉल्ड पास्कल्स ट्रायंगल इसमें डिस्क्राइब किए हुए हैं। सो दिस आर वेरी ओल्ड, बहुत ही ऊपर जो पिंगला जिसने छंद शास्त्र लिखे थे उसका एज था 500 BCE के आसपास, सो लाइक 2500 years बिफोर टुडे। फिर थिंग्स लाइक जीरो, डेसिमल सिस्टम, प्लेस वैल्यू सिस्टम जो हम यूज करते हैं, खगोल शास्त्र, एस्ट्रोनॉमी, फिर एल्जेब्रा जिसको कि संस्कृत में बीज गणित या अव्यक्त गणित कहा जाता है, फिर थिंग्स लाइक नेगेटिव नंबर्स, फ्रैक्शंस, देन कैलकुलस, कॉम्बिनेटोरिक्स जो हम स्टैटिस्टिक्स वगैरह में पढ़ते हैं, स्टैटिस्टिक्स प्रोबेबिलिटी थ्योरी में, combinatorics and astronomy, and not just this, but even as it may come as a surprise that even the subject of calculus, which is जो हम न्यूटन और लाइबनिज को एट्रीब्यूट करते हैं, वो भी विकसित हुआ था केरला में, इंडिया में, like 2-3 centuries उनके पहले, before Newton and Leibniz. So ये these are some of the details which जो मैंने इस पुस्तक में इंक्लूड किया है। और एंड ऑल्सो लाइक मेरा और इंटरेस्ट था, जैसे कि मैंने आपको बताया था कि ये सब नॉलेज, मैथमेटिकल नॉलेज पूरे विश्व में इसका विस्तार कैसे हुआ, थ्रू व्हाट मीन्स, थ्रू व्हाट चैनल्स, ये भी एक बहुत इंटरेस्टिंग चीज है जो जिसके बारे में शॉर्टली बात करूंगा। और एक और बात है कि इस मैथमेटिक्स का विकास का बहुत घनिष्ठ संबंध रहा है हिंदू सभ्यता और रिलीजियस स्पिरिचुअल थॉट के साथ, फिलोसॉफिकल थॉट के साथ। तो जैसे कि हमने देखा था रामानुजन इज अ गुड केस इन पॉइंट ना, क्योंकि ही वाज वेरी मच कनेक्टेड विद हिज गॉडेस, तो वो गॉडेस को प्रे करता था, एंड थ्रू दिस he had even said कि every equation of mathematical equation to me is the word of God. So this is a very interesting thing, and even Hindu mathematicians they used to be very closely connected with the religious and spiritual roots. Then and finally fourth point is ये सारा information absent क्यों है? तो हम अगर आप पूछोगे किसी को हैव यू हर्ड ऑफ न्यूटन, यस न्यूटन का नाम सुना है, हैव यू हर्ड ऑफ गॉस, कार्ल फ्रीडरिश गॉस, यस सुना है, हैव यू हर्ड ऑफ ब्रह्मगुप्ता, किसी ने नहीं सुना, एटलीस्ट मैं ऐसा जर्मनी में रहता हूँ, नोबडी हैज हर्ड ऑफ ब्रह्मगुप्ता और भास्करा, राइट? तो सो एक्चुअली so these some of the things why it is absent from mainstream accounts. So ये एक पॉइंट था जो मैं एड्रेस करना चाहता था। और इस टॉक में मैं एक्चुअली बहुत कुछ सवाल मेरे को बहुत फ्रीक्वेंटली आते हैं कि मैंने इसको हिंदू मैथमेटिक्स नाम क्यों रखा, मैंने इसको इंडियन मैथमेटिक्स या कुछ और ज्यादा न्यूट्रल नाम क्यों नहीं रखा। और कुछ लोग पूछते हैं कि ऑन द अदर हैंड कि आपने इसको वैदिक मैथमेटिक्स क्यों नहीं रखा, बिकॉज यू नो या Vedas also from the Indian subcontinent. और फिर तीसरा सवाल आता है कि बट व्हाई हिंदू एट ऑल, मैथमेटिक्स तो सेक्युलर है, मैथमेटिक्स तो यूनिवर्सल है. तो दीज आर इंपॉर्टेंट क्वेश्चंस, इसलिए मैं इसको एड्रेस करूंगा पहले शॉर्टली. तो एक रीजन मैं इसको हिंदू मैथमेटिक्स बोलता हूँ और इंडियन मैथमेटिक्स नहीं बोलता, वो ये कि इंडिया एक पॉलिटिकल एंटिटी है जो कि 1947 में इसका जन्म हुआ था, जबकि हिंदू सभ्यता है वो थाउजेंड्स ऑफ ईयर्स पुरानी है, एटलीस्ट 5000 इफ नॉट मोर. तो यूजिंग द वर्ड इंडियन मैथमेटिक्स इस फैक्ट को एम्फेसाइज नहीं करेगा. सो दिस इज द थिंग, मैं इंडियन मैथमेटिक्स नहीं यूज करता हूँ. एंड हिंदू मैथमेटिक्स ऑल्सो इज अ नेम जो कि एकेडमिक्स यूज करते हैं, विच वाज वेरी कॉमन 20th सेंचुरी में, इवन एकेडमिक्स में, वेस्टर्न और इंडियन एकेडमिक्स के साथ. फिर दूसरी बात ये कि जो बहुत सारे जो मैथमेटिकल आइडियाज है हिंदू सभ्यता में, दे आर क्लोजली कनेक्टेड विद द स्पिरिचुअल आइडियाज. सो इफ आई यूज द वर्ड इंडियन, ये कनेक्शन नहीं एम्फेसाइज होता. तो इस वजह से भी मैंने ये वर्ड हिंदू मैथमेटिक्स यूज किया है. और दूसरा सवाल यह आता है कि व्हाई नॉट वैदिक मैथमेटिक्स. सो द रीजन इज मैंने हिंदू मैथमेटिक्स आई हैव नॉट यूज्ड इट इन द रिलीजियस सेंस. हिंदू मतलब इट डज नॉट मीन हिंदुइज्म और हिंदू इन द सेंस ऑफ जो हम रिलीजियस सेंस में सोचते हैं, बट इट रिफर्स मोर टू द सब कॉन्टिनेंट, इंडियन सब कॉन्टिनेंट की दिस सिविलाइजेशन ऑफ स्प्रेड. कहाँ पे जो आज अफगानिस्तान है, जो आज पाकिस्तान है, बांग्लादेश है, और जो आज इवन कंबोडिया, वियतनाम है, थाईलैंड है, ये सभ्यता इस पूरे रीजन में स्प्रेड था. तो इवन थाईलैंड में, आज थाईलैंड में द रामायण बहुत इम्पोर्टेंट, इज ए वेरी इम्पोर्टेंट टेक्स्ट इन रामायण इन थाईलैंड टुडे. ये जो आप तस्वीर देखा था आपने प्रीवियस स्लाइड पे, ये था एक टेम्पल है अंकोर वॉट, डेडिकेटेड टू लॉर्ड विष्णु. ये है कंबोडिया में है. सो फॉर ऑल दीज रीजंस आई थिंक द वर्ड हिंदू मैथमेटिक्स मेक्स मोर सेंस. एंड वैदिक मैथमेटिक्स क्यों सेंसिबल नहीं है मेरे ख्याल से, क्योंकि वैदिक रिफर्स टू ओनली द वैदिक ट्रेडिशन, जबकि इन द हिंदू सिविलाइजेशन देयर हैव बीन आल्सो जैन एंड बुद्धिस्ट स्ट्रीम्स ऑफ थॉट. एंड देयर हैव बीन इवन जैन ट्रेडिशन से बहुत सारे देयर हैव बीन वेरी इंपॉर्टेंट मैथमेटिशियंस इन द जैन ट्रेडिशन, जैसे कि महावीरा, हेमचंद्रा, यहाँ पे लिखा है वीरसेना, उमास्वाति एक्सेट्रा. So these are some reasons कि मैंने ये I have used the word Hindu mathematics and not Indian mathematics or Vedic mathematics. तो दूसरा सवाल ये आता है कि why did I use the word Hindu at all? Like because mathematics तो secular है, mathematics तो universal है, so आपने इसको इसके साथ क्यों कनेक्ट किया है? तो इसमें बहुत सारे पॉइंट्स है. एक तो पॉइंट ये है कि जो वर्ड सेक्युलर है ये सब स्पेसिफिकली वेस्टर्न कंसेप्ट है, तो इसका कनेक्शन चर्च के साथ रहा है सेक्युलरिज्म में, तो इट हैज अ वेरी टोटली डिफरेंट कॉन्टेक्स्ट, हिस्टोरिकल कॉन्टेक्स्ट, और इट मेक्स नो सेंस टू impose this idea on the Indian context. Okay. और and secondly, अगर कुछ universal है तो it should be like हर civilization में it should be equally valid. जबकि Indian subcontinent में, Indian civilization में the use of negative numbers was totally fine, but negative numbers was not accepted in the Arabic mathematical scene. नंबर्स का जो विकास हुआ था इंडिया में, यूरोप में बहुत टुक सेंचुरीज, सदियों लगे, जबकि बिफोर दे वर एक्सेप्टेड इन यूरोप. अगर मैथमेटिक्स सही में यूनिवर्सल होता, इंडिपेंडेंट होता सिविलाइजेशन से, देन दीज डिफरेंसेस इनको अराइज नहीं करना चाहिए था. तो ये कुछ एस्पेक्ट्स है. सो मैं इसको बहुत ही जल्दी से आई विल जस्ट रैप इट अप. हाँ, एक और बहुत इंटरेस्टिंग बात है कि बहुत सारे वेस्टर्न मैथमेटिशियंस रहे हैं, हिस्टोरियंस रहे हैं, वो क्लेम करते हैं कि दैट मैथमेटिक्स इज यूनिवर्सल, बट एट द सेम टाइम दे क्लेम दैट मैथमेटिक्स इज वेस्टर्न. सो दिस इज लाइक अ कॉन्ट्रडिक्शन. इट इज यूनिवर्सल बट इट इज वेस्टर्न. सो हाउ कैन दिस बी, राइट? आई मीन यू हैव, आपके पास यहाँ पे कुछ स्टेटमेंट्स है फ्रॉम सम वेस्टर्न मैथमेटिशियंस. जैसे कि वन आई फाइंड वेरी इंटरेस्टिंग इज द ग्रीक्स आर द फर्स्ट मैथमेटिशियंस हु आर स्टिल रियल टू अस टुडे. Oriental mathematics may be an interesting curiosity, but Greek mathematics is the real thing. And किसने लिखा है ये? You can see who has written this. It is G.H. Hardy, the man who made Ramanujan famous, right? So these are very pertinent points जिसे हमें consider करना चाहिए when we speak about the history of mathematics. Okay. So these are some of the general things जो मैं discuss करना चाहता था. And now I think any questions so far, I will be happy to take a few short questions before I go to the next. Or comments. Comments also are fine. Yeah.
I might little bit go off topic, but I want to talk about something else.
Mm-hmm.
Like, do you know about AI?
AI का
talking recently that the phone will get hacked and everything like that. So I'm asking that will AI be harmful in future or not? If science get development further in AI technology.
Yeah, actually, this is the good question. It depends on the way how is science formulated. So if the science believes that human beings are just matter and human beings are just resources, then the people who are in power, they will of course arrange for it in such a way that you will be treated as a resource, and then so that is the danger in that. Apart from that, this battle between the hackers and the law enforcement agencies, this will go on. This has been the battle for that's the since the beginning. Yeah, that's what I would say. Okay. Okay, I'll continue करूँगा. So some of the major mathematical developments in the Hindu civilization. So I will speak about first the Sulba Sutras, because these Sulba Sutras are Vedas का एक part है, और इसमें certain geometric rules दिए हुए हैं Vedic altars को बनाने के लिए. तो वैदिक यज्ञ जब किए जाते थे, उनके altars हुआ करते थे, जिसमें you see this altar here, square shape altar. तो उसमें different rules चाहिए थे, like how to create an altar whose area is the sum of two other altars. या फिर how do you create a square altar whose area is the sum, whose area is the same as the area of a given circular altar of a given radius. तो इस प्रोसेस में इनके जो फॉर्मुलेटर्स थे, जो सुल्बा सूत्रास के जो फॉर्मुलेटर्स थे, उन्होंने बहुत सारे मैथमेटिकल ज्योमेट्रिक रूल्स दिए थे इन ऑल्टर्स को बनाने के लिए. तो इसमें there is a lot of important and interesting mathematical information hidden in these sutras. So और ये सब वेदास के पार्ट है, as I said, and these are dated to about 800 BC. So there are some major Sulba Sutras writers. So Apastamba, Baudhayana, and Manava, and Katyayana. So इन सबके Sulba Sutras है. So Sulba basically इसका मतलब है rope, रस्सी, क्योंकि रस्सी यूज किया जाता था measurements करने के लिए. So that's why the word Sulba Sutra comes. Yeah. So and इसमें बहुत सारा geometric information है, लेकिन the most important I think for our purposes is that it contains the first ever statement of the so-called Pythagoras theorem. So this is from Baudhayana Sulba Sutra. So yeah, it's basically written in terms of rectangles. और यहाँ पे जैसे कि mention किया है, the Sulba Sutras का जो attributed date है, it is 800 BCE. But this is like a lower estimate. It's quite possible they are much older, but I just don't want to go into that discussion right now. So I've just taken the commonly accepted date of 800 BCE. But nonetheless, there is like 3 centuries ka difference hai between Pythagoras and the Sulba Sutras. So okay, and yeah, so Sulba Sutras ka first publish हुआ था, like the English translation of the Sulba Sutras published हुआ था 1875 में. By G. Thibaut. तो उसमें इस तरीके से the Western world को परिचित हो गया सुल्बा सूत्रास के साथ. Okay. और फिर 1901 में एक German translation आया by one guy called Albert Burke. तो this is the thing. And और जब हम Pythagoras theorem की बात करते हैं, there is one thing is that the statement is given in its full general form in the Sulba Sutras. The second thing is that many people don't know about this, but इसका कोई evidence नहीं है कि पाइथागोरस ने ये थ्योरम डिस्कवर किया था या उसको ये थ्योरम पता भी था. This is actually very important point, but this is how myths are created and propagated. Okay, there is कोई evidence नहीं है कि पाइथागोरस को ये थ्योरम पता था. तो यहाँ पे एक थॉमस हीथ है, the most well-known writer on Greek mathematics. तो उसके पुस्तक में A History of Greek Mathematics, Volume 1, he says it clearly. Okay. Although this theorem is universally associated with the name of Pythagoras, no really trustworthy evidence exists that it was actually discovered by him. So ये tradition rise हुआ around 4 centuries के बाद, after 4-5 centuries after Pythagoras. So later authors they ascribed this result to him. Okay, and so this is how this myth arose, and this is how it is propagated all through this. I mean, I know this is very difficult for many people to digest, but that is how it is. So, okay. And although इसमें कोई proof नहीं है कि Pythagoras ने theorem discover किया था, result discover किया था, still people have been propagating this myth. So for example, in Thomas Heath, the same author के किताब में वो लिखता है कि I would not go so far to deny to Pythagoras the credit of the discovery of our proposition. I like to believe that tradition is right and it was really his. तो ये basically श्रद्धा की बात हो गई. It's a matter of faith. श्रद्धा की बात हो गई कि I like to believe, and that is how this thing is propagated. So, and एक और चीज सूर्य सूत्रास के कॉन्टेक्स्ट में बोलना चाहूंगा कि not only is सूर्य सूत्रास में the result is given in its most general form, लेकिन इसके constructions में there is also a proof implied of why this theorem is true. So ये है एक idea. तो आप इसके जो further details है आप यहाँ पे देख सकते हैं, जैसे कि ये by article by A.K. Datta, Mathematics in India Part 1, 2002 का article है, bhavna.org.in/mathematics in India. So it's by A.K. Datta. So it's a very nice article. इसमें he has given a lot of information. And in addition मैंने यहाँ पे picture पे एक 1929 का article का snapshot दिया है from a German historian called Konrad Müller. तो उसमें ये he shows ये proof कैसे implied है in the about Sulba Sutra constructions. तो yeah, I mean like यहाँ पे एक square है यहाँ पे और यहाँ पे एक और square है. Then you basically want to prove that आप ये इस साइड को यहाँ पे ट्रांसपोज कीजिएगा और फिर ये जो बनता है इसका जो एरिया है, this area is equal to the area of this square and this square. Okay, that is basically nothing but the Pythagoras theorem as we know it. So like he writes here, ich glaube in der Tat, dass dies der Weg gewesen ist, auf dem die Inder, this is the way I really believe that this is the way the Indians discovered the proof of the Pythagoras theorem. So I have actually just made a small animation for you. Maybe you can have a look. So yeah, so you just basically transpose this triangle here and this one here. So this will not change the area of the whole shape. So the area is then equal to this square. So a square plus b square equal to c square. Okay. So yeah. Okay. So okay, then Sulba Sutras as regards the I will skip this part actually. यहाँ पे I wanted to just मैं बस यहाँ पे एक कुछ बातें बोलना चाह रहा कि why the Sulba Sutras have been neglected in the history of mathematics. So there are दो बहुत अच्छे articles हैं by one historian called Abraham Seidenberg. तो उसने Sulba Sutras, Babylonian mathematics और Greek mathematics का बहुत deep study करके in these two articles, the ritual origin of geometry and the origin of mathematics, इन दोनों articles में इसमें बहुत अच्छा interesting information इसमें describe किया है. And he speaks about that the importance of the Sulba Sutras in the context of mathematics history. So इस paper से कुछ snapshots मैंने यहाँ पे दिए हैं. लेकिन I think the most important is this. A common source of the Pythagorean and Vedic mathematics is to be sought either in the Vedic mathematics or in an older mathematics very much like this, like it. What was this older common source like? I think its mathematics was very much like what we see in the Sulba Sutras. So it's a very interesting statement. So that it's like Sulba Sutras is basically the origin of the Greek mathematics. From there it all started. So these are some of the things which are really important and interesting in the context of the Sulba Sutras. Okay, I think this would be the part for the Sulba Sutras in general, and I will go on to the next topic, which is zero number system and arithmetic. So yeah, basically yeah. So we all know that zero comes from India and the number system also comes from India. But what is the why is it so important? इससे पहले जो ग्रीक और रोमन सिस्टम था ऑफ नंबर्स, यू कुड नॉट, आप बड़े नंबर्स नहीं रिप्रेजेंट कर सकते थे, आप उसको अरिथमेटिकल ऑपरेशंस नहीं कर सकते थे. सो विद द हिंदू नंबर्स लाइक विद जीरो एंड द डेसिमल नंबर सिस्टम, प्लेस वैल्यू सिस्टम, आप दोनों चीज एक साथ यू कुड सडनली डू. आप बड़े नंबर्स भी रिप्रेजेंट कर सकते हो एक फाइनाइट सेट ऑफ सिंबल्स के साथ, 10 सिंबल्स इन द केस ऑफ द डेसिमल, और आप इसके साथ अरिथमेटिक ऑपरेशंस भी कर सकते हो, एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन, क्यूब रूट्स, स्क्वायर रूट्स. या So this is the ये सबसे बड़ा progress था in the history of mathematics, one of the biggest progress. क्योंकि आप जब astronomical calculations करना चाहते हो, you have to use big numbers, right? So these kind of things, and also हर field में numbers के बिना आप you cannot do anything, any calculations. So okay, so as I said, for example, अगर हम Roman number system का उदाहरण लेते हैं, तो इसमें अगर आप 4888 represent करना चाहते हो, then it becomes something like this. Okay, it's really complicated. और दूसरी बात यह है कि ये जो नंबर सिस्टम को आज हम बहुत ही सिंपल और बहुत ही ट्रिवियल मानते हैं, बहुत इजी मानते हैं, हम स्कूल में पढ़ते हैं, बहुत इजी है, हम समझते हैं. लेकिन बात यह है कि इसको यूरोप में इसका प्रचलन होने के लिए सदियों लगा. यूरोप took centuries to get used to this number system. 3-4 centuries कम से कम लगा, शताब्दी लगा before Europe got used to these number systems. तो इसमें बहुत ही interesting मैंने passage पढ़ा एक पुस्तक से, टोबियास डैंटसिक, The Number, the Language of Science, 1945 का ये पुस्तक है. इसमें ये लिखता है, there is a story of a German merchant of the 15th century. It appears that the merchant had a son whom he desired to give an advanced commercial education. He talked to a prominent professor of a university for advice where he should send his son. मतलब एक जर्मन मर्चेंट था, वो उसके बेटे के लिए एक कमर्शियल एजुकेशन देना चाहता था उसको, और उसने किसी को पूछा कहाँ पे वो इस कमर्शियल एजुकेशन को भेजे, किसके लिए भेजे. तो वो आदमी बोलता है इससे कि if the mathematical curriculum of the young man was to be confined to adding and subtracting, he could perhaps obtain the instruction in a German university. But the art of multiplying and dividing, he continued, had been greatly developed in Italy, which in his opinion was the only country where such advanced instruction could be obtained. So it's really like interesting, when हम इसको historical context में सोचते हैं इसके बारे में. So yeah, there are some philosophical associations with this. The number 0, आप इसको कैसे number का status दे सकते हैं जबकि इसका कोई value या magnitude नहीं है. Like 1, 2, 3 हम उनको देख सकते हैं, but 0 को कैसे देख सकते हैं. And और दूसरी बात ये है कि जैसे कि रोमन नंबर सिस्टम में the number 6 आप लिखते हो V and 1, so वो 5 plus 1 बन जाता है. जबकि इंडियन सिस्टम में अगर आप 5 के साइड पे 0 लिखोगे तो वो 50 बन जाता है, लेकिन 0 as such का कोई वैल्यू नहीं है. तो by adding nothing to something it becomes 10 times. If you add 2 times it becomes 500. So the same number becomes changes its value depending on adding 0 to it, putting a 0 to it next to it. So I will just skip some philosophical aspects of this. लेकिन मैं एक और चीज है कि जब आप 0 की बात करते हैं तो closely connected to 0 is the concept of infinity. क्योंकि अगर 0 है तो आपको infinity होना ही पड़ेगा. क्योंकि you have division of numbers, at some point आपको सोचना पड़ेगा what is division by 0. So you have to think. तो Indian civilization में infinity was if we add or subtract from it, anything from it. So he compares this with just like there is no change in the infinite Lord Vishnu due to the creation or dissolution of living beings. So this actually exactly this idea आपको मिलेगा also भगवद गीता में. तो there is no change in the supreme divine person, no matter how many people are born or die, they all remain in this. So incidentally ख का मतलब in Sanskrit is space. तो इसी से you also get the word खगोल शास्त्र, astronomy, the study of space. तो space is like और इस भगवद गीता के श्लोक में भी लिखा हुआ है space, that all beings that just there everywhere remains always space है उसमें. I won't go into the translation, but this is the very interesting thing. And other things that not just 0, not just the number system. So Hindu mathematics में negative numbers were compared with debt, ऋण, or positive numbers were compared with wealth. So इसके जो rules थे for negative, etc. तो ये सब rules इसने यहाँ पे in verses में describe किए हैं. So ये मेरे ख्याल से these are बहुत ही important verses हैं in the history of mathematics. So they should really be like, somewhere, displayed in gold letters. Okay. So I think I will take a very short pause. कुछ सवाल हो तो मैं ले सकता हूँ. And I will just take some water also. किसको क्या? Second, ये वाला. Yeah, like a bigger magnitude and a smaller magnitude. Okay. Yeah. Okay. Yes.
Differentiate between 0 and infinity.
What's the what?
Differentiate between 0 and infinity.
Differentiate. What is differentiate?
The difference between them.
The difference between 0 and infinity.
Can you say something like that?
I mean, well, it's like 0 is a small number. Sorry?
0 is also infinity, we can say also.
0 is also infinity.
Yeah, something. Like we can also say that 0 is an infinity because you can divide it.
अगर आप change of transformation करते हो, some transformation, then you can convert 0 to infinity, of course. I mean, if you take x to 1 by x, then they become, you can think something along those lines. But apart from that, I don't understand the question.
We can also convert x 0 into infinity. Like there is no difference between them. Like infinity can also be 0, 0 can also be infinity.
I don't know how. Maybe you are another Ramanujan using the t-shirts. Yeah, maybe you're thinking but whenever if arithmetic closely connected to arithmetic is a subject of algebra. क्योंकि arithmetic में आपको specific numbers होते हैं जिसके साथ आप arithmetic operations करते हो, subtraction, addition, etc. But and these are specific numbers. Now we come to the subject of, and this is also called Vyakta Ganita in the Hindu tradition. Arithmetic is known as Vyakta Ganita. Vyakta मतलब क्या? Something that is manifest, something that is concrete as a form in front of you. उसको व्यक्त कहते हैं, जो व्यक्त form में आपके सामने उपस्थित है. और अव्यक्त क्या है? जो आपके सामने उपस्थित नहीं है, वो है लेकिन आपको दिखाई नहीं देता. So the word for algebra in Sanskrit is avyakta ganita. तो और बीज गणिता. तो actually algebra is a बहुत ही अच्छा उदाहरण है जिसमें कि आप connections देख सकते हैं mathematical ideas और Hindu spiritual and philosophical ideas के साथ. तो ये बहुत ही very good example for seeing this connection. तो तो इसमें क्या होता है कि algebra जैसे कि हमने स्कूल में पढ़ा है कि आपको किसी unknowns चाहिए आपको, तो आप वो unknowns को किसी symbols के थ्रू रिप्रेजेंट करते हैं और फिर आप एक इक्वेशन सेटअप करते हैं और वो अननोन को आप सॉल्व कर देते हो बाय सॉल्विंग दैट इक्वेशन. तो और दूसरा यूज ऑफ अलजेब्रा ये भी है कि आप सिंबल्स के साथ आप जनरल रिजल्ट्स एक्सप्रेस कर सकते हो. जैसे कि एक राइट एंगल ट्रायंगल लेते हो, उसमें a स्क्वायर प्लस b स्क्वायर इक्वल टू c स्क्वायर लेते हो, ये एक जनरल रिजल्ट है जो आप सिंबल. तो इसमें तो जैसे बोला था कि आप इक्वेशन देखते हो a स्क्वायर प्लस b स्क्वायर इक्वल टू c स्क्वायर. एज आई मेंशन्ड इट इज ऑल द राइट एंगल ट्रायंगल्स. तो ये जो इसको अव्यक्त कहा जाता है इस फॉर्म को. तो इन द हिंदू फिलोसॉफिकल ट्रेडिशन जो व्यक्त संसार है वो अव्यक्त से उत्पन्न होता है. ओके. So that is also the idea which was expressed by, for example, Bhaskara too in his Siddhanta Shiromani 12th century में. तो उत्पादकम यत् प्रवदन्ति बुद्धेः अधिष्ठितं सत्पुरुषेण सांख्याः व्यक्तस्य कृष्णस्य तदिक बीजम अव्यक्तमीशं गणितं च वन्दे. So he says here that I revere that unmanifest supreme power unmanifest supreme power is this avyakta. Okay. Avyaktam Isham, unmanifest supreme power, whom seers describe as the origin of clear intellect buddhi and as the sole cause or the bija for all that is manifest. तो इसका double meaning है. ये तो हो गया ये in the spiritual sense, or even in the mathematical sense he says that I revere that avyakta ganita. I revere that avyakta ganita, which mathematicians declare to be the generator of clear thinking and as the sole cause of basically arithmetic. So I don't know if I was able to express this, but like the avyakta is the source of the vyakta. So here this is, and I have मैंने यहाँ पे श्लोक यहाँ पे discuss किया है, but I think I will just skip this part. So skip this part, and actually जो मेरा जो किताब का title है, The Imperishable Seed, also comes from this same idea, because avyakta ganita is also called bija ganita. Bija, why bija? Bija is the seed. So what kind of seed? It is this seed from which the vyakta ganita arises. From the avyakta ganita, the vyakta ganita arises. So likewise, जो हिंदू फिलोसफी में जो पूरा संसार है, विश्व है, वो अव्यक्त से उत्पन्न होता है, और उस अव्यक्त को बीजम अव्ययम कहा गया है. फॉर एग्जाम्पल ये भगवत गीता में, the imperishable seed. So this is also the source of my book's title. And यहाँ पे algebra में some common facts की, जैसे कि आज हम x use करते हैं एक symbol को denote करने के लिए, तो in the Hindu algebra texts they used to use the word यावत तावत, और इसको shorten करके या को shorten किया करते थे, या. So ya is the x of today. ये यावत तावत is a Sanskrit word for as much as, the quantity to be found. Okay, और फिर अगर additional variables थे तो उसको alphabetical letters का use किया करते थे, प्रयोग किया करते थे, या फिर कलर के नाम का प्रयोग किया करते थे, और नेगेटिव नंबर्स को वो एक डॉट से रिप्रेजेंट करते थे. सो 100 उसके ऊपर डॉट लिखा, 100 हो गया. तो और जो हम आज लेफ्ट साइड और राइट साइड में इक्वेशंस लिखते हैं, इक्वेशंस, तो इन द इंडियन टेक्स्ट वो लेफ्ट हैंड साइड एंड राइट हैंड साइड की जगह अप एंड डाउन लिखा करते थे. सो दैट फॉर एग्जांपल यहाँ या 6 रू 300 है. रू का मतलब है प्लस. सो रू इज ऑल्सो द शॉर्ट फॉर्म फॉर रूप. रूप मतलब समथिंग कॉन्क्रीट या व्यक्त. व्यक्त और रूप, रूप है किसी का रूप होता है, नाम और रूप, दैट वुड बी व्यक्त. सो या 6 रू 300 मतलब 6x + 300. और नीचे लिखा है या 10 रू 100, या वर्ड डिनोट किया करते थे. वर्ड इज शॉर्ट फॉर्म फॉर वर्ग और स्क्वायर. And there are also other advanced things like so-called Pell's equations, Kutaka and Chakrawala equations, which are really, I hope to go into it right now, but these are also like really well-known and advanced mathematics which we do algebra and methods especially.
How ancient people were able to calculate the speed of light or distance between the Earth and Sun?
Speed of light, I actually don't know how this was done in the ancient times.
But how were they able to calculate that?
I don't know how they did in the ancient times. Recently there were other experiments like Fizeau's wheel and all those kind of things physics may. But I don't know about if and how they did in the ancient times. This I would not know. But there are certain references in the Hindu scriptures which apparently, talk about the speed of light. I have not authenticated that or examined that. और दूसरा सवाल क्या पूछा था?
How they calculated distance between Earth and Sun?
Okay. This is like, again, इसमें you have to go into like, eclipses, shadows and those kind of, geometrical constructions. Very complicated. I cannot go into it right now, but one can definitely, read those things in more detail in the, text of Bhaskara and like Brahmagupta. Yeah.
May I ask something?
Yeah.
So the picture we can see on the last slide, what's the resource for that? The equation you explained.
Yeah.
That picture is from where?
That is from Bhaskara II's work, Bija Ganita. So this actually, he speaks about it is an equation for horses and wealth. Somebody has so many horses and so much wealth. Yeah, this horse cost. Yeah, it actually means I don't remember exactly, but yeah, it's like this. I remember now: 6 horses one man has, and 300 rupees or whatever the currency was. This one particular person has. The other person has 10 horses and has a debt of 100 rupees or whatever, and their wealth is equal. So how much is the cost of one horse? Yeah. So this would be from Bija Ganita, Bhaskara's. So in school school में हम trigonometry का subject पढ़ते हैं. Trigonometry is a very important subject. I don't have to emphasize that. And as it happens, trigonometry का development भी Hindu civilization में ही हुआ था. And in fact, ट्रिग्नोमेट्री को जो हम बोलते हैं, सो आज जो कॉमन ट्रिग्नोमेट्रिक फंक्शंस है, साइन, कोसाइन, टेंजेंट, इट्स वेरी इंटरेस्टिंग. मे बी यू मे हैव हर्ड अबाउट दिस, आई डोंट नो. लेकिन आज जो हम साइन फंक्शन यूज करते हैं, that actually comes from the Sanskrit word where it was known as ja, became ardha ja, because this is the half of Indian lands. तो ये जो वर्ड ja था, इसको ट्रांसलेट किया पर्शियन में as jaib. It was a mistranslation and इसको ट्रांसलेट as jaib. और jaib का मतलब होता है like a pocket or a fold. jaib का मतलब अरेबिक में. और जब ये अरेबिक वर्ड्स books were in turn translated into Latin, तो उन्होंने fold का literal word in Latin use किया, that was sinus. So sinus is how ja से we got sinus. And similarly, cotic ja is the word for cosine, and that became cosinus. So yeah, अभी जो बात बताई थी अभी यहीं पे है. और फिर most of the जो identities हम स्कूल में लर्न करते हैं, sin of x plus y, cos of x plus y, and sin of 2x, all those things in the trigonometric circle. And also the fact कि sine और cosine के signs change करते हैं. Sine and cos are both positive in the first quadrant, and those kind of things. Sine is positive in the second quadrant, cosine is negative. All those kind of things, they were discussed in the Hindu civilization. I won't go into it again, but yeah. And jumping from trigonometry to combinatorics, the Indian mathematicians also did a lot of results in combination for NCR, how many combinations of R objects. So in his Ganita Sara Sangraha. And the next topic I will talk about is linguistics, prosody, and computer science. Again, I have to keep it really superficial. So linguistics क्या है? मतलब it's a study of language. Okay, and Sanskrit में the subject of linguistics was really highly developed. So Panini, from 500 BCE, he wrote the book Ashtadhyayi. तो his aim was very interesting. उसका aim था, दो aims थे. How can you break a sentence into smaller blocks, and how can you use smaller blocks to produce all possible sensible sentences. So the first one is okay, it's fairly easy, but the second one is really, really more complicated, because they also have to make sense. So he gave all these rules for making such things in a set of about 4,000 rules. उसने describe किए 4,000 rules or sutras, और इसको इसने अष्टाध्यायी में compile किया था. His work, इसका नाम था अष्टाध्यायी, और इसके बहुत सारे rules recursive and iterative spirit में है. And और फिर यूरोप में लिंग्विस्टिक्स का शुरुआत हुआ ओनली व्हेन ये अष्टाध्यायी का ट्रांसलेशन यूरोपियन लैंग्वेजेस में किया गया. और पाणिनि ने एक सो कॉल्ड आइडिया डेवलप किया था जो कि कंप्यूटर प्रोग्रामिंग में यूज किया जाता है. इट्स द सो कॉल्ड बैकस नॉर फॉर्म व्हिच इज एट्रिब्यूटेड टू जॉन बैकस, लेकिन उसका पहले डिस्क्राइब किया था पाणिनि ने. सो आप सोचते होंगे कि कंप्यूटर साइंस और लिंग्विस्टिक्स का क्या रिलेशन है. एक्चुअली इट्स अ वेरी डीप रिलेशन, क्योंकि जब आप कंप्यूटर प्रोग्रामिंग करते हो, प्रोग्रामिंग के लिए यू हैव टू कंप्यूटर को जो आप इंस्ट्रक्शंस देते हो, इट हैज टू बी एज क्लोज एज पॉसिबल टू ह्यूमन लैंग्वेज. Okay, so that's how you can see immediately the connection between computer science and linguistics. So many of the ideas of Panini are relevant for computer science. So okay, and then closely connected to the subject of linguistics is prosody. Prosody मतलब the study of poetic meters, छंदा जिसको कहते हैं. तो आपने सुना होगा गायत्री छंदा, अनुष्टुप छंदा संस्कृत में. You may have heard of it, I don't know. But in English में उसको meters कहा जाता है, poetic meters. So I don't know if I have the time for going into details, but it's like the sky is blue. इसमें if you take this sentence, you have 4 syllables. तो अगर आप हर syllable को एक time unit attribute करोगे, like long or short. So for example, the sky is blue. The को if you can say it consists of 1 second or 2 seconds. And the sky also it consists of 1 second or 2 seconds. So how many possibilities will you have? You will have basically 2 to the power 4 possibilities. The 2, 2, 2, 2. So you have 2 to the power 4 possibilities. So in sense where you have something like so the Pingala was one of the most important prosodists who was the creator of the Chanda Sutras. So this type of poetic meters, which 2 to the power n, 2 to the power n kind of number of poetic meters, which I had just spoken about. He discussed the so-called Meru Prastara in this connection. So this is what is today known as the Pascal's triangle. So there is unfortunately no board, otherwise I would have shown it here, but it's okay. Or Pingala maybe, he also gave the description of the first ever binary number systems. So there is a nice article by Van Newton, Binary Numbers in Indian Antiquity. So this way you can look at the mathematical technical details, why he came up with this idea of basically converting a decimal number to binary and vice versa. And in the same topic of prosody of Chanda Shastra, you have this very interesting sequence, right? So ये एक अगर आपके पास सिर्फ एक syllable है, okay? अगर आपके पास सिर्फ एक time duration है, so you can have either short time duration or long time duration. Okay, so if you have a short time duration, तो आपके पास एक ही possibility है. अगर आपके पास एक long time duration है, which consists of 2 short, आपके पास 2 possibilities है. That is a long one and 2 short ones. Like I don't know if it's clear, but it's like I hope it's clear. This is basically two time units, and this is 1 unit plus 1 unit. So in total it is 2. So इसमें भी देखोगे आप, it is 1 time unit and 2 time units. So 1 and 2 is 3. So 2 and 1 is 3, and 1, 1, 1 is 3. So you have actually 3 possibilities here. अगर आपके पास 4 time units है, तो आपके पास 5 possibilities है, क्योंकि 2 and 2 is 4, and 1, 1 and 2 is 4, and if you list out all the possibilities, you get 5 such possibilities. And similarly, if you have 5 time units, if you count out the possibilities, you have 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if you continue like this, 1, 2, 3, 5, 8, the next one you will get is 13. Okay. And each number is obtained by the sum of the previous 2 numbers, and this is nothing but the Fibonacci sequence. So yeah, here are some references synced in the so-called Fibonacci numbers in ancient and medieval India. And this was discussed by Virahanka in the 6th century and Hemachandra in the 11th century. So this was all before Fibonacci lived. Okay. Or here I have given the Sanskrit text from Hemachandra, from his Chandoru Shasana. So if you read this Sanskrit text and read his description, you will see that, so antya upantya, anta upa anta. So the last one and the previous one. So tayor yoga, their sum. Okay. Paraspara milanam, pare pare sthane. So basically if you just read this, you will get the rule of what we just saw. Sn is equal to Sn minus 1 plus Sn minus 2. So, yeah, exactly. So, any questions before I just move on to the next one or something? Any comments? Yeah, just go to the next one. Okay. In the subject of calculus, also, we think that Leibniz and Newton are the originators of calculus, and it is a very strange claim because in Europe there was no tradition of mathematics till about the 14th, 15th centuries. Then they came to know of the decimal number system, and suddenly within the space of 1 or 2 centuries, suddenly you have the birth of calculus and all these discoveries which take place, which is really like it takes some imagination to really believe that, because it's just that we have been taught like this since childhood. We think it is true, because for the development of any field of knowledge, you need centuries of background for that. And in the Indian subcontinent, the study of calculus is exactly the same situation. So, starting from Aryabhata sine tables, 5th century, in the Aryabhata he wrote his sine tables, and his sine tables are really interesting. They are not just a list of values for the sine function at different angles, they are second order sine differences. And in this case, to build these tables, he implicitly makes use of the of the fact that the second order derivative of the sine is equal to the minus of the sine function. So, जैसे कि d2 by dx square of sine x is equal to minus sine x, right? So that is the kind of idea he uses in the discrete version, and this is how it developed through the centuries by various mathematicians for interpolating functions and all those kind of ideas. And finally, it was brought to its highest point in Kerala in the 14th century, starting from Madhava in the 14th century and his disciples Nilakantha Tantra Sangraha, Nilakantha Jeshtadeva, Shankara Varman, etc. So it is these people from Kerala, they developed the so-called Taylor series for sine and cosine functions. So this आपने ही देखा होगा अपने school books में sin x is equal to this series expansion for sine and cosine, then so-called Taylor expansion, and or this expansion series expansion also for the inverse tangent function. This you also may be aware of. Tan inverse x is equal to given by this formula, and if you just substitute here I think x is equal to 1, then you get tan inverse 1 is nothing but 45 degrees, pi by 4. So pi by 4 is equal to, you get the so-called Leibniz series. So these results were discovered by Madhava and his followers, and much before they were discovered in Europe in the 17th, 18th centuries. So yeah, right. I just skipped this one. Okay, and जैसे कि मैंने बोला था कि I want to also discuss also how this work was transmitted to the rest of the world. So the works of Bhaskara and Brahmagupta, not Bhaskara, but Aryabhata and Brahmagupta, they were transmitted to the Arab world and they reached Al-Khwarizmi. So in the 7th century also, 7th, 8th centuries. So because I don't remember exactly the date, in the 8th century I think there was the first invasion of Sindh from the Middle East. And then after that, the Arabs and the Persians, they found their way to India. And from there on, they had this connection to India. And then the Indian mathematical texts were sent to the Arabic world and translated there. So basically, Al-Khwarizmi's book on arithmetic, he calls it as, Kitab al-Jambal Tafriq bil Hisab al-Hind. So he calls this explicitly as Indian numbers. Okay. And Al-Khwarizmi's algebra and astronomy and trigonometry also were based on the Hindu mathematical works. So, yeah, there are many resources for this. I have just given here one, this article. So, and finally, these works from Arabic and Persian were translated into Latin by the European translators. And that's how the Indian number system reached Europe, and the ideas of algebra and trigonometry, etc., they all reached Europe this way. And yeah, so and finally, I would also like to talk about this very less well-known fact. I don't know, if you are familiar with this aspect, the transmission of calculus to Europe. There is, unfortunately, no documentary evidence, but there is a lot of circumstantial evidence which speaks for the fact that calculus, the ideas of Kerala mathematicians, they made their way to Europe. So, yeah, I mean, so I think it's probably getting a bit too late. Shall I just skip over these aspects very fast? It's too late. Yeah, I'll just quickly wrap up now, yeah. Yeah, and then... okay, I just wrap this up. Yeah, and I'll just probably finish off with the last slide. Why is all this so important? Why do we as Indians need to know about this? I will try to, I have switched to English, I don't know how. Sorry. ये सब इतना महत्वपूर्ण क्यों है? हमें क्यों पता होना चाहिए हमारे सभ्यता के मैथमेटिक्स के बारे में, हिस्ट्री के बारे में? कि बहुत लोग ये बोला करते हैं कि अच्छा भैया आपने इतना सारा किया है पहले, लेकिन आज आपका कंट्रीब्यूशन क्या है? आज आप क्या कर रहे हो? बहुत लोग ये प्रश्न पूछते हैं. तो इसमें एक्चुअली आई थिंक इसमें बहुत इम्पोर्टेंट ये है कि अगर हमको हमारे इतिहास के बारे में पता नहीं है, तो हमको ऑलवेज एक इन्फीरियोरिटी कॉम्प्लेक्स रहेगा कि हम वेस्ट को फॉलो करना चाहिए और वेस्ट हमसे सुपीरियर है। तो ये एक जैसे कि अगर आप स्कूल में हो और आपको पता चलता है जब आप कैलकुलस पढ़ते हो कि ओ अच्छा ये टेलर सीरीज इंडिया में डिस्कवर हुआ था, केरला में डिस्कवर हुआ था, और फिर ऑल दिस ट्रिग्नोमेट्री कॉम्बिनेटोरिक्स ये सब इंडिया में डेवलप हुआ था, तो आप सोचो आपका क्या कनेक्शन बन जाता है मैथमेटिक्स के साथ। आपको ऐसा नहीं महसूस होता है कि आप एक एक फॉरेन कल्चर को स्टडी कर रहे हो या फॉरेन साइंस को स्टडी कर रहे हो, बट इट बिकम्स टू यू कि आप समथिंग वो स्टडी कर रहे हो जो आपका ही है, एंड दैट दिस मेक्स अ बिग डिफरेंस आपके एटीट्यूड में टुवर्ड्स द सब्जेक्ट, एंड दिस लीड्स ऑब्वियसली टू मोर क्रिएटिविटी एंड टू मोर progress, as it's called, so, and more originality, and right. So this is one thing, and second thing is that if we don't know, अगर हमें हमारे इतिहास के बारे में नहीं मालूम है और अगर हम blindly वो accept करते हैं जो हमें पढ़ाया गया है, which starting from the British rule, British times, then how can we expect to be original by if we are just हमारा sense of identity comes from some external sources. So these are some of the things, and yeah, probably that's it. Thank you very much for your attention. Yeah.
If is there, please raise your hand. So thank you so much, sir. Such a nice math talk and told about a history of maths in Indian subcontinent and how it is closely related with Hindu religious, spiritual and philosophical thoughts. Definitely this talk will inspire younger generation to explore more wonder of maths for Vikshit Bharat. Thank you so much, sir. So now I would like to request Dr. Narottam Sahu, sir, to felicitate sir with memento.
Sir, 1 minute.
Thank you so much, sir. Yes. Now we proceed for a vote of thanks. So now I would like to request Mr. Pavish Shah, sir, Scientific Officer of GUJCOST. Please come, sir.
I take this opportunity to thank all the dignitaries who have spared their valuable time. Dr. Bhaskar Kamble sir, Dr. Vinay Kamble sir, for from their busy schedule they have arrived here, and our students got opportunity to talk to you and know the past, our ancient past and glory of our Indian culture, that we used to have all this mathematics with us, but now the students can explore it in a better way. So thank you so much for your wonderful address. I would like to thank Dr. Harshad Patel sir, Vice Chancellor of Indian Institute of Teacher Education, for providing this wonderful venue to carry out this program. I would like to thank Dr. H.C. Patel sir, Registrar of this university. He also graced the inaugural function also. I would like to thank Dipti madam for your she totally took care of this organization, including inaugural ceremony, volunteers from IIT, students of IIT, faculty members of IIT, for their wonderful help and support to all GUJCOST staff member. And I would like to thank all the audience, students, participants, also all other participants for attending this program. So, lastly but not least, Dr. Narottam Sahu sir, advisor GUJCOST, for conceptualizing this program, and all the team members, Dr. Poonam Bhargav madam, Jalak Ben, Sangeeta Ben, Devangi Ben and all other team members of GUJCOST. Thank you so much. So now we will leave for the canteen downstairs for having some high tea and snacks. Thank you. Before leaving, I request all you please rise for national anthem. Then we'll go.
भारत माता की
बंद कर देजो यूट्यूब और पते अरे अरे अभी उसमें बोला ये बुकी दो परेशान कर
સ્ટુડન્ટ્સ આપણે બેક સાઈડથી નીચે કેન્ટીન
पवित्र